26 and 27, TI-84 plus calculator, mini tab output. Same question though, can you reject the null hypothesis? Again, it doesn't matter if this is a 2-sample t-test, 1 sample t, 1 sample z, 2 sample z, doesn't matter, same analysis. Traditional method versus the P method. I'm doing the same thing, doing it again and again and again and again. Traditional method. So we're testing the null hypothesis is mu1 equals mu2. Two means are equal. Alternative hypothesis, mean 1 is greater than mean 2. This is a right-tailed test. This is right-tailed. There's my critical region. So we're talking about degrees of freedom are 24.49. We can call that 24, right? 24.49. Let's go to the t-distribution table. 24 degrees of freedom, 0.05 is alpha. Where's that table? Here we go. 24 degrees of freedom, one-tailed, 0.05, right? 24 degrees of freedom. Oops, there we go. One-tailed, 0.05. 1.711. 1.711. All right, let's check it. All right, so now we're checking that t-test statistic. This 2.237416. It's definitely greater than 1.711. So that means we reject. It's in the critical region, so we reject the null hypothesis. All right, let me just double check. We have 24 degrees of freedom, 0.05, that's one-tailed, 1.711. Oh yeah. Now the P method. P, so if I'll rewrite it here, if P is less than or equal to alpha, reject the null hypothesis. If P is greater than alpha, do not reject the null hypothesis. So in this case, P is 0.982794. Alpha is 0.05. So in this case, P is 0.9 is greater than 0. So wait a minute. So this says do not reject the null hypothesis. Did I do something wrong here? P is definitely greater than alpha, so don't reject the null hypothesis. But here, degrees of freedom 24.49. Yeah, see, that's a little weird. You know that we get these degrees of freedom that aren't a whole number, right? Because n should be a whole number. I don't know. I think something might be off with this data. If you see something that I did wrong, just mention it in the comments, and we'll sort it out if I did something wrong. But I don't think I did. Yeah, if you think I did something wrong, let me know. So I'll use the same two methods here, traditional. So I don't know what the answer is to 26. I'll just say that. I don't know. And the P method. So we have all the same information here as the problem before. This is a test of the null. Is the difference is 0. So mean 1 minus mean 2 is 0. Or mean 1 equals mean 2. Alternative is mean 1 minus mean 2 is not 0. Or mean 1 does not equal mean 2. This is two-tailed. This is two-tailed. Still a t-test, right? Still a t-test. And we want to test this t-statistic when we get a chance. So here, the degrees of freedom are 17. Sounds more reasonable. Alpha is 0.05. Two-tailed. Degrees of freedom 17. Alpha is what? 0.05? Yep. Degrees of freedom are 17. Two-tailed 0.05, 2.110, and negative 2.110. 2.110, negative 2.110. Those are my critical regions. If my t-value lies in either of those regions, reject the null hypothesis. T is 1.07, somewhere in here, 1.07. It's not in my critical region, so do not reject the null hypothesis. Let's hope we come to the same conclusion with the p-test, p-method. P is 0.299465. Alpha is 0.05. P is definitely larger than that. 29 is larger than 5. So do not, P is larger than alpha, right? Do not reject the null hypothesis. So can you reject H sub 0? No. Can you reject H sub 0? IDK. I don't know. You'll tell me if you think you know, or if you do know.